Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to figure out if you are Moody. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, we're lucky to be joined by our two panelists, Stacy Thibodeau and Brad Poznansky. Stacy holds degrees in both biology and chemistry and a master's degree in educational leadership. She has been in the science classroom for 21 years and currently teaches at Southside High School in Youngsville, Louisiana, where she teaches robotics and chemistry 1 and 2. She has also taught biomedical science courses in the Project Lead the Way program, as well as Chemistry 1 and 2 AP. She uses TI technology to assist her teaching, data collection, and modeling math concepts, linking them to science content. Stacy, thanks for joining us tonight.
Thanks for having me, Mike. I'm excited to share what I get to do with my kids. Thanks.
And Brad's in his 25th year teaching mathematics at Comstock High School. He has been using TI technology in his classroom ever since he student taught. He is a firm believer that you never stop learning, and that is evident in his pursuit of new and innovative challenges made possible through TI technology. Brad has presented at local, state, national, and international conferences. Brad coaches 3 varsity sports and loves to sail in the Caribbean. Who doesn't? Brad, thanks for joining us tonight.
Thanks for having me.
We're expecting a large crowd, and so your audio is muted. Feel free to send any questions to Stacy or Brad using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, at the bottom of your screen, there's a audio broadcast button that you can try and toggle that on and off. At this point, Stacy is going to discuss our agenda.
Thanks, Mike. So Brad and I will introduce ourselves initially, kind of where we're from and what we do in our classrooms with TI technology. And then hopefully we will give you some ideas of how to add coding into your STEM classroom, whether it's a mathematics or science or a just general STEM class. And then if time allows, which we hope it will, we just have so much to cover tonight, some STEM camps or clubs ideas that you could possibly do.
That's exciting. Thanks, Stacy. And Brad is going to discuss our expected outcomes.
Okay, some of our expected outcomes tonight are going to be to code some short programs in TI Basic, which is on the 84 CE or the TI-Nspire CX platforms. And the new coding language that TI has introduced is Python, which is available on the TI-Nspire CX II, which is an exciting new language for us to explore. Part of the outcomes is to understand programming logic and flow in both basic and Python languages, right? With the differences in syntax. One of our outcomes that we hope to achieve is to investigate a sensor and an output project for you to use immediately in your classroom with the TI Hub. And ultimately, we want to leave you guys with many ideas for what you could use in your STEM projects in your classrooms immediately.
Brad, thanks so much. Stacy, you should have control. Feel free to share your screen.
All right. So like Brad mentioned, and we kind of talked about in the agenda and the outcomes, and Mike with his silliness about Moody. So there's a STEM project called the Mood Ring, and it's basically an introduction to coding that you can put into any classroom. And then the TI has a website, and on the website has all of the instructions, documents. You're going to get all that tonight. Okay. So if I talk really fast, I'm from South Louisiana, so I talk really fast. So if it's tonight's too fast for you, this webinar is being recorded, and you'll get a link to the recording a couple of days afterwards. And then feel free to go back, pause, with your handheld, that kind of thing, back and forth, because it's a jam-packed hour. So this is our contact information. You'll have this as well in the documents if you need. Brad or myself be more than happy to have conversations with you if you need about the STEM projects. And then we both are also on Twitter and post different things that we're doing with our students. If you're looking for ideas, both of us have innovative ideas that we do with our classroom. All right, so Brad, you want to talk about why we do STEM?
Absolutely. STEM is just so exciting to be able to use in the classrooms. It's transformed the way I've taught, and definitely what I've seen the students doing from your traditional classroom. Once you start introducing STEM topics and STEM ideas, the students definitely start interacting much more. All right, they're working together. They're working with students that they never probably would have teamed up with before. Listening to their just conversations and the communication between the students is outstanding. You just sit there and listen and just absorb everything they're saying, and it's just so exciting to see them excited about learning different ideas. The creativity is amazing, because once they start getting engaged in this, you hear them saying, "How do I do this? Can I do this? What if?" And all those different types of creative ideas that I've been teaching at the secondary level for forever, but you always hear those with younger kids. They're always what ifs, and so it's nice to see that being reintroduced. And we have some real world problems that you can introduce with them, but at the same time is how they can extend what they're learning to that. And finally, the last part there, the critical thinking. So that's kind of fun because they're challenged every time they come up with a solution. As a teacher, as an educator, I think we should keep challenging them to be able to see how they can apply their learning. So that's the critical thinking aspect. And the fun part with the STEM is definitely to connect the math and science. As a math teacher, for 20 plus years, you get so used to a certain way with math, and so it's been great. I've working with Stacy and other science teachers, where you can pull them into what your classroom is and see how you can interconnect the two disciplines there.
Yeah, absolutely. One thing that people always ask me is why do I include STEM and STEM focus in even my chemistry classroom? And the graphic on the right-hand side is why. As secondary teachers, we are preparing kids for jobs, and we have to do a good job of the classroom teacher to make sure they have the skills. And doing these types of projects, I really feel that my kids are ready for whatever career path they're interested in. Brad?
Yeah, I'll jump in for this
Okay.
one. Right? So,
Okay.
So Stacey and I, we've included some images of stuff that we've done in our classrooms with our STEM classes. This is the first year that we've actually run in my high school an official STEM class, and we titled STEAM. We wanted to throw the art in there, whether it's music or graphic arts. And so we started out. My district was very supportive. They were able to get us the equipment we needed, and it was more of a free form. And I think that's one of the things that you can't be afraid of is trying new things, seeing how they work. A lot of times the students, with their questions, hey, can we do this? What about that? It gives you a lot of ideas of the possibilities. And so some of the technology you can see there, we were using some of the TI rovers. You can see that the kids aren't afraid to get down on the ground. The bottom slide, bottom photo there, that's our COVID group. So it was definitely a challenge, as was be for everybody throughout the country this year, as far as cooperative learning and what's allowed and what's not allowed. And then one of the things that, if you see the Pac-Man up there in the upper left corner, that we were able to kind of do a little mini unit on was a little bit of animation. And the idea is that the students came up and making certain images move across their screen, really integrated, definitely some artistic ability, some geometry, and they didn't know it, but they were integrating some, for loops and some, mathematical equations as they were doing it.
Cool. So this is from my classroom. My class is an introduction to robotics because that was one of the pathway classes that was already created. This is my first year teaching it as well. And so I just put some pictures of different projects that my kids did. Some of these are housed on the TI website under the STEM projects. Some are things that I took and we kind of made our own. So top left is smart irrigation project. That's actually the first STEM project I did at a workshop, a TI workshop, and realized that I needed to do more of this with my students. So it uses sensors like we're going to use tonight and has an output of a motor, a pump, excuse me, to pump water when it's ideal conditions to water a garden. Bottom, my students actually created their own conductivity sensor. And so we used a veneer conductivity sensor to figure out what was the actual conductivity of the water. And then we created one with a breadboard design. Dispenser project, again, there's a sensor of a motion sensor. And then when the hand is there, there's a little motor that turns and dispenses. In this case, it was some beans that I had lying around. Bottom is a jukebox where the hub is housed inside. Looks like an old iPod. And it plays music and it has lights. And then top right is kind of where we're headed tonight to make a mood lamp or a mood ring. So this is the TI Innovator Hub that Brad and I use in our classroom. And so this is our interface. This is our, excuse me, microcontroller that Texas Instruments put out a couple of years ago. They realized not only the need for STEM skills, not just in education, but their own future workforce. And so created this box, this hub that's how the microcontroller is housed in a very sturdy plastic design that even middle school students can use. I've never used it with elementary, but I've gone all the way down to the 6th grade level. It has a variety of ports that are for input, so sensors, like we're going to use tonight. And there are out ports for things like a motor, like my automatic dispenser, or a pump that you could add. There's also a brightness sensor that you could use that's part of the hub in the mechanics, and you don't have to plug in anything extra. The I2C port connects the rover as well as some other parts. And then the data is how you connect your handheld. And I'm going to show you a little video later. This is just an example at the bottom of how all of the components can fit into the hub and, you know, be housed in a smaller space. So that's the hub. Brad, you want to talk about 10 minutes of code?
Oh, sure. So on the TI website, education.ti.com, they do have a piece where it's the 10 minutes of code. It's a great entry level spot to be able to learn, you know, just basic introduction to the code. It's very step by step, gives you a little bit of background, a little bit of knowledge of each particular aspect of coding. All right, from just your basic output and basic input to using them in, you know, various loops. And also they will, you know, have, you know, modules that you could follow that, you know, will allow you to use the hub, the rover. And now that they're using Python, it'll allow you to do that as well. So no matter what handheld you're using, you'll be able to integrate that into you know, your handheld. So if it's an 84, you can use that 10 minutes of code with both the hub and the rover. If you know you have the CX, you could do that as well. And if you are fortunate enough to, you know, get one of the new CX2s, you can do basic on there and Python. So you know, it's all different levels, and it's a great way of starting out. And it's going to spark your interest in what you can do, what, you know, what you want to do with it. And I think it's just a great starting point. And you know, it'll probably, you know, cause you more questions than answers initially, because you're like, how do I do this? You know, you're going to get excited about it. And you know, that's the great part of it is you know, where can you go from there?
Absolutely. So this is how I got started. And so I'm a chemistry teacher, always been a chemistry teacher, went to a conference, saw this in action. And I was like, this is kind of cool. I need to figure this out. And I met a TI buddy who happens to be on the webinar tonight. And we started doing this together. And she does not live in Louisiana. She's not down my hall. So to have somebody to go back and forth with, and then you start meeting other people who are on Twitter, like Brad, and I was like, hey, how do you do this? Show me how you did that. But it all started for me with the 10 minutes of code. I sat down with my handheld, sat down with my innovator, learned how to do it, troubleshoot back and forth, and then went and presented it with my students. Once you do it with your students, then the students will show you things that you didn't even know. Like Brad was mentioning, they're like, can I do? And I'm like, I don't know, let's try it. What kind of code should we write for it? And put it back on the kids. But I'm not a computer programmer. That was not my expertise. And so TI has made it really user-friendly for any level of a programmer to actually get started with it in their classroom. All right, so we are going to put a lot of information. So the 84 CE is TI Basic. It's all menu driven. And so usually the first program, if you were in a programming class and you were doing it on a computer, is a Hello World program. And so on the 84, you can actually do that type of a program with a display. And so I'm going to show you in a second on the emulator. And so that's always kind of one of the first programs we write. And the kids are like, ooh, I wrote something. And you're like, all right, let's try something else. So then we write programs to be stored on the handhelds to use for specific calculations. And so this is part of 10 minutes of code. You start with Hello World. You start with mathematics-based formulas so they understand, in this case, display statements. And a prompt, which is for them to input, and then a formula for them to figure out. And so what the program does is it asks the user to enter the hydrogen ion concentration, and it spits out the pH. So not with the innovator, but still getting the students to understand programming language. So on the CX, which is, they also has the TI Basic. You can also do the same program. Notice it looks different. It does have a display, but you're still able to get the same aha because it's their first program. And that's what I would start with when you're first starting with the students, is get them to do something that they're going to have lots of success with initially. And then this one is what my buddy that I was talking about. She teaches a Bio 2 class, and they needed to know solute potential. And so she had her students actually write this program looking at something that they use all the time in AP Bio. And then Brad, you want to talk about this one you wrote in Python?
Sure. So having programmed in BASIC for a while, transferring into Python has been an interesting journey. There's many things that are the same, and it's just a matter of the syntax and how they're coming out. So here is basically the same program as Hello World. I just decided to change it up. And so one of the similarities here, if you see that screen on your left-hand side, is that clear history. So that's very similar to the clear on the TI-84. And to my knowledge, I don't think there's one of those on the basic for the TI, the CX in the basic. So here it's a print instead of a display statement, and it'll display that text on the screen. So it's a nice, there's your output piece of it. As a math teacher, and sometimes when I'm not teaching a STEM class, I'm trying to figure out ways of engaging the students to kind of use the technology to do something that they normally do. So here's a program that I quickly wrote with my ninth grade algebra class, and they didn't come up with this on their own. I mean, full disclosure, right? But it was kind of a selfish plug for our STEM class that they could take as sophomores. So they were doing some factoring and having to try to figure out the factors of a number. So I showed them this program, and I just kept on spitballing at them saying, hey, give me a number. And all of a sudden we were just, giving all the factors, and they were like, oh, wow, how'd you do that? So again, it was getting them interested to say, oh, wow, I'd like to learn how to do that. So here was just, a application for them to use a program to be able to figure this out. Now, I think if a kid could program this themselves, they might not have a problem figuring out the factors of 76. However, it could be a hook for them to say, hey, this is really something neat that I want to learn how to do. And, dealing with 4 classes of ninth grade algebra, that's my aim, is to try to, recruit students to get into those STEM classes and have that excitement about it.
And understand why coding is important, not just in the application of the innovator, but in something that would be an everyday task that might be a little more difficult to do. Yeah. All right, so Brad's going to talk to us about for loops because we are going to add some loops into our mood ring. We will get to it, I promise. But we just wanted to give everybody kind of an overview, not knowing, who's on the webinar, who's going to watch it, the recording. All three, the 84 CE with BASIC, the CX with BASIC, and the CX2 with Python, have the same it's a program language. And so if you write a flow chart, no matter what flow chart you're using, you should be able to go through. We are going to demonstrate a few things in a minute, but I wanted to let Brad kind of talk about his for loop discussions.
All right, so there's many types of loops that we can use. And I think one of the first ones that we introduce, and also if you follow along in the 10 minutes of code, is a for loop. All right, it'll perform an activity many times. All right, so it's a very repetitive activity or command, and you could tell it how many times to do what you want to do. So as we see on this slide, the first piece, and I put it just in quotes there, the variable, right? So you're going to determine a variable that would be the index or indice of this loop. All right, so you would just define a variable there. All right, you're going to start it at a certain number, you're going to end at a certain number. So you might go from 1 to 5, or maybe 1 to 10. That last piece where it says step is going to be how much is it going to count up from. So if you started at 1 and your step is 2, the next time through it would go to 3, and then it would go to 5, and then it would go to 7. So that last step there, you don't necessarily have to include, because by default it'll just increase by 1. All right. So then this is a chance where would we need a loop? What would we be doing that might have us doing something repetitively? So if we want to ask some of the participants, maybe you have an idea, why would you want to do something several times and have something very concise like this to do it several times? So if anybody has any ideas what you might want to use that for, we'd love to hear about them. And Stacy just posted in the chat. Excellent. Yeah, motion and robotics, absolutely. I'm sure Stacy would concur with using the rover when you're trying to draw some polygons or make it move. Absolutely. Thanks, Adam. Right. So so now within the loops within each programming, so with the TI-84 CE, when you ask for a for loop, as you see on the screen there, that's all it gives you. It just gives you 4. All right, so you're going to have to know that you're going to include a variable. You're going to have the start. You're going to have the stop. On the right-hand side there with the TI-Nspire for the CX or CX2 with the basic, you can see right there, they give you the for and those 2 commas, right? So right before the first comma, you would include your variable. And then after the first comma, you would tell you where you're going to start. And then after that, you're going to tell it where it's going to stop. And if you wanted to count by anything other than 1, you would include that as well. Now, one of the differences here is in the basic for the Nspire, they have an end for statement. All right. And in this the TI-84, you're going to have to include that end statement. All right. So there's always little differences in the syntax and how you're going to go about them. All right, so here's 2 examples of the same loop being executed. All right, so here on the left-hand side, you have we just call it the demo loop. All right, so your variable is I. All right, and it's going to go from 1 to 5, and all it's going to do is it's going to take that variable I and it's going to square it. All right, so the first time through, the variable I is 1, it squares 1. Next time through, it'll be 2, it'll square 2, and so on. All right, until it goes all the way up to 5 and it becomes 5 squared. You can see the subtle difference on the right-hand side where very much the same with the commands, and it has N4 built in, and your output in either program is exactly the same, right? So they're basically, they're exactly the same loops, all right? So that's kind of a unique thing about these 2 is, it might look a little bit different, all right, but your menu commands will be essentially the same. Now, I think we got the next slide coming up.
I thought, okay, sorry.
All right, you're gonna run it?
We were gonna go program. We are.
Oh yeah, here we go. So, well, let's just bring this one slide up, please.
Yep, no problem.
All right. Awesome. All right, so here within the CX2 with Python, all right, I just wanted to put this slide up there, and we wanted to share it because there are 3 different for loops, all right, just the way they write them, all right? So top left, all right, that index is going to be that variable, all right? And then the first one just says in range size, all right? So that's going to be where it ends, all right, the size. The middle one, very similar, you still have your index there. One of the nice things about the Python language that they have on the CX2s is they have these fields that kind of tell you what to put in there. You know, they're giving you some indication of what they want there, as opposed to a blank that they're, you know, requiring you to remember what it is. All right, so it's very user friendly. In the middle slide there, it tells you where it's starting and stopping, and then the third one, it's a start, stop, and how big do you want to step with. All right, so I think Stacy's going to demo for us.
So Brad's going to tell me what to do.
We're going to talk you through. All right, so we're going to create a new program.
Whoops, so sorry. I always hit the buttons too fast. I did that last night too. Sorry.
All right, so we're going to go to A for add a Python program, and we'll call it new. And for simplicity, we'll just call this loop 1. All right, and so we're going to try to, you know, do one of those loops, just like we did on the 84 and in the Nspire Basic. All right, so this is menu driven. So if we just press the menu key, we have all sorts of options here. All right, and so number 4, where it says built-ins, and we're going to be doing a control command. So number 2 for control, and this is where we have those 4 statements. All right, there are actually 4 of them. We're going to use either 4, 5, or 6. So let's choose number 4. All right. We're going to choose a variable I. And if we press the tab key, it'll just bounce us to the next field. So just like those other loops, we want it to end at 5. So we're going to choose 5 here. And then if we press tab, we're going to go into the block. And here we're going to go to menu. And then we want to go to our built-ins. And we want to output something, all right? So that number 6 is IO, stands for input output. And number 1 is going to print something.
So in Basic, it was a disp, right? It was a display, and in Python, it's a print.
Yep. So okay. That's the difference between the two. And so we're not going to display any text here, all right? So what we're just going to do is we're going to take that variable I, and in Python, if we want to square it, it has a little bit of a different notation. So we're going to, and we could use the keyboard there if you do the raise to button. So I think it's going to be just right there. See how it has 2 asterisks. That's in Python, that means you're going to raise it to a power, and we're going to raise it to the 2nd power. All right.
So pause for 1 second. I'm sorry, Brad. So what I'm doing is what I would do with my students, right? And so we're going to start, and I show them whatever skill I want for the day, the week, whatever. So if it's for loops, I'm going to demonstrate just like we're doing right now. I would walk them through, and Brad too, what we want them to accomplish by a certain time or a task. And so if you're new to TI technology, there's the handheld on the side that every time the key is pressed, the key turns red. And so the students can follow along. And then as the teacher, if you're writing a program in front of the whole class, you don't have to use the keypad. You can use, your actual keyboard of your computer. Or if you're writing a program you're going to send to them, it's much easier to program on the premium teacher software than it is on a handheld. So this is kind of modeling what we would do in a classroom. Thanks, Brad.
Absolutely. No worries. All right. So now, just like I would do in class, you might want to, if we've been programming with BASIC, and that's what we did with my STEM class this year. It was prior to the Python coming out. And so we were just doing a lot with BASIC. So this would actually be a fun activity to say, hey, what do you expect to see when we run this program? Right. So, do you guys think that we're going to get from 1 to 5 squared? Anybody have any ideas? All right, so we're going to run this and see, I'm expecting this to go from 1 squared to 5 squared, just like those other 2 programs were. So in order to do that, we're going to press Control and R. and it automatically runs it for us, right? So this is unexpected here, all right? I didn't expect to get 0, 1, 4, 9, and 16, right? So I know that we were asking it to square whatever the variable was, all right? And we told it to stop at 5, but we got from 0 to 16. This is kind of interesting. So, all right, let's try another loop, right? Because there's another loop that tells us where we could start and we could stop. Let's compare that. So let's do a new program. So we're gonna go Control Doc. All right, we're gonna get used to just creating programs. Number 1, and we'll call this loop 2. All right, so we're gonna go through the same process where we're gonna press Menu, and then we want to go to number 4 for the built-ins. You're gonna get very used to these places, and then number 2 for our control. All right. This time, let's use that loop that says where it's starting and stopping. All right, we want to start it at 1 and stop it at 5. All right, that's what we want to do. So we're going to put an I for our index, and then you're going to tab to start. And here let's start it at 1, and then we're going to stop it. So you press tab, it'll move the field over. We're going to stop it at 5, and then if we hit tab, we'll get right down into that for loop. And so we want to print out I squared again. All right, so let's go to menu. And then it's still within the built-ins. And this is an input output. So number 6. And we want to output. So we're going to print this. All right, so we're going to print I squared. So we're going to do I. And then we're going to do raised to. And then the second. Now,
Hey,
one thing
Brad,
I do want to point out here
hey,
is that
I know sometimes like when you're running a program, if you have the same letter, same variable, it like gives you a syntax error. And we're okay with this because page 1.1 is the editor. That's a totally different program and it has a different name, right? And so page 1.3 is a totally different program, different name. So I can have the same variable I, right?
yeah, excellent.
Okay,
Absolutely great
awesome.
point.
Okay.
So before we run this, I do want to point out that, and it just dawned on me, is like, if you notice, we don't have an end for statement in the Python loop. Right, so that's one difference, that you do not have to have an end for, just, and that indentation where you see those two gray diamond looking shapes, that's indicating that that's part of that whole loop. All right, and so it's inside that loop. So let's run this and just see what happens. So wow, we went 1, 4, 9, 16. So we were able to go from 1, start at 1, which is where we wanted to start, but then it ended at 4 squared. All right, so if we just go back one page, just so we could take a look at this program, all right? And one of the things about Python, when you're doing these for loops, right, the end of it, that 5, all right, it does all those variables, in indices up to 5, but does not include it. So it's less than or equal to 5, right? So, that's one thing to keep in mind. So when you're doing some of these programs and you're learning, keep them simple like this, where you could just be like, okay, that makes sense, versus you're trying to do, from 1 to 100 or something like that, and you're not sure about it. So it's a nice way to keep it smaller and learn those little pieces. Now, on the previous one, if we go back to 1.1 stage, just one real quick. All right, here where they don't have a start and stop, Python's default will always start at an index of 1 or indice of, I'm sorry, I apologize, indice of 0. And then go up to just 4 in this case would be 1 less than the range.
So Brad asked a while ago, like where would we need for loops in programming in your current class? With these projects, most of the time we have for loops in there because they're crucial to have automation of our project. So no kid wants to sit there and press enter the whole every time for a program to run and get a value and do something. So having the for loop and the background information of what the limit or the output is of the for loop is really important when you're starting basics with the students to understand how programming languages work. So that's why we wanted to spend some time on it tonight, especially with the new version of Python. With the variety of the different for loops, it looks different, and then you can have different types of outputs based on what your needs are. All right, mood ring project. Okay, so 10 minutes of code, definitely get started with 10 minutes of code with your students. If you want to spend some time doing it before, I highly recommend it. That way you have, you feel, comfortable doing it in front of the whole class. And then this is probably the first project I would do with students. One right now, it has all three platforms, the 84 basic, the TI CX basic, and then the TI CX II Python, all on the TI website with teacher documents. There's planning documents, there's videos. It's really the best way to kind of get into programming with some of the mechanics. So what you're going to have is a temperature sensor. And this sensor is going to come into one of the inputs that I showed you guys on the hub. And then based on the temperature, we're going to get the temperature. And based on that temperature, we're going to use an if-then statement. And so if the temperature is whatever, then you have some output. Before my students actually run the entire program of anything, anytime we try a new either input or output, we play. They plug it in, they touch it. I let them figure out what their finger temperatures are, what their hand temperatures are, the inside of their arm, so that they can understand the range of temperatures before they just go at it. If it, like when I did the conductivity, we created our conductivity sensor, same thing. We played before we ran our entire project. So I would have my students play around with this and then create the parameters that they wanted for the display, whatever output we wanted. If we wanted an output of a light, which is why we're doing a mood ring. And so there's a colored LED, an RGB LED that's embedded into the hub. It's automatically in the hub. There's no output port for it. It's just part of the hub. And you can have a variety of colors and then have a display statement based on the temperature. So some of us that are a little bit older than others, and I think they kind of coming back, mood rings, you'd put it on. If it turned a certain color, you read the little description and it told you if you were stressed or if you were anxious or calm or whatever. And it's not anything scientific, but it's also really fun for the students to understand this is my input, this is my output, and then they can do it multiple times. So again, the documents are all there. If we were running in the TI Basic on the 84, this is what a program looks like. And I'm going to show you, we're going to run one in a second, from the TI Connect software. So I got started programming with Inspire first with the on a CX in Basic, and the STEM project started coming out, and they were like, "Hey, Stacy, you want to learn how to program on the 84?" And I was like, "Sure." And then I was like, "Oh, this is different, but it's challenging, and it's also it makes me use like I feel like a different part of my brain because Inspire looks so different." So I actually enjoy programming on the 84. So the 84 has two components for its software. The TI Connect CE is probably my favorite software to program on if I am going to create a program either to download to save for myself or to send to a student's calculator, or if I need to retrieve a program from the TI website or from somewhere else. And so I can always open a program or create one here. And it's easier here because I can use my keyboard of my computer. If you use the emulator software, the Smart View, like we were showing earlier for the Inspire, you have to use the keypad of the handheld. So it makes it a little more challenging, but at the same time, it's still, I don't know, I just think it's fun. I'm also a big nerd and I like to do stoichiometry and chemistry. So for us in programming on the 84, it's the PRGM. I already have obviously some several programs that I've done. I'm just going to go and create a new, just real quick to show you. And so I would select one. And so it wants me to name it. I'm just going to call it Stacy. That's my name. And there it is. And so now I can write whatever program I want. Under PRGM, now that I'm in a program editor page, I have pretty much the same availability, like Brad showed us with Python, it just looks a little different. So if I wanted a 4, that's my number 4 right here. If I wanted to put an output of a display statement, number 3. If I wanted to do the clear home, I could do that. If I had an input, and then if I was using the hub, then this is the hub control menu. So similar to kind of what we saw with Python, all menu driven. Okay. So if you were showing with students on your 84, definitely use the Smart View. If you are creating a program just for yourself, or if you needed to connect to a handheld and send it to a handheld, or if you were downloading from the website, I would use the Connect CE. So that's a little bit about the 84. This was one of the documents I was telling you about. I used it when I did the mood ring with my students, and I've used it for every project since, that are major projects, so that they have a flow chart. They know what constraints are. And so I just change it, the document for whatever project I'm on. So if it was conductivity sensor, what were some of the conductivity levels they read? And then I had known salt concentration solutions. And so when they put it in there, what was the reading? What was the salt? And then they were able to create a graph, and we got mathematical models, and then we got some unknowns. And anyway, so then we wrote our program for what we wanted our sensor to have an output for, and they did different things. So I thought this was kind of cool to have a document to start with, to be able to go with the students with something. All right,
yeah,
so this,
I'm just going to
I'm
jump
sorry.
in real quick for a second. So one of the things I do like about that project, especially like, so the documents that they have, you could make this into, man, like probably a 2-week long project. Absolutely. With the levels of just exploring the color and exploring the input output from the temperature sensor. So those are great things. And then even just the ability for the students to have ownership of what colors they choose, that excites them beyond anything. You show them possible colors, and they're like, oh, I love purples, I love, blues, whatever color it is. And, you show them how to like do the RGB values on like just in a simple Google search and with a slider, and you could show them different RGB values, and they just get so excited about, they take ownership of their colors. So those are always some great things for the students to have their ownership of their project.
Absolutely, yeah. So this is with the CX in TI Basic still. So I just put screenshots. This one's a little more complicated. This is actually part of the materials that you're going to get tonight. My students did not write this, but I would have them write one initially, and then that way they can feel ownership and success, and then send them this one, and then they modify the temperatures based on their body temperature. That's always a good way to start with students, is possibly send them the file that has the code, and then they modify certain parts for themselves. If they don't want red to be to say calm or whatever, they want to change it, they can put something else. Sometimes students want to have their own characteristics in there. So let me show you real quick on the CX. I promise we're going to get to Python. Brad's going to show us some stuff. So this is one of the documents that is going to come to you in the file folder in a little while. And so like Brad was mentioning, you could do this with your students for an extended period of time. So these are some mood messages they could have. Now these files, once you download them, or when you get the file folder later, they're yours. You can edit them. You can change some of the text. You can add, you can take away. It's yours. And so sometimes I don't send my students a huge file. I'll send them one page. And so today they get the one page, and maybe tomorrow they get other parts of it. And so it has the objectives. And then this one is Python, where they're learning through. But it's a whole document that walks them through the entire part of the project. So let's say I wanted to create a basic program very similar to what we did a while ago. We did new. This time, this is going to be under Program Editor. So this is under for the TI Basic. And if I want to call it, I'm going to call it Stacy. Why not? It's my night, right? So the setup looks a little different. It says define, and notice it's in bold, and that means that that's our variable name. That's our program name. And then I tell my kids everything is going to be in the sandwich between PRGM and end PRGM, or in program. We want to keep everything in there. So under menu, looks the same, right? We have some of the same things. We have control, like Brad showed us. We had that earlier. We have IO. Brad talked to us about that. We have hub. So a lot of the same is all on all three components. It's just maybe in a different spot. So if I were doing this to actually set this up, the first thing you have to do is connect the temperature sensor. So you're going to have a temperature sensor that comes in, and then based on the temperature sensor data and levels, then the students have an output. And so we would connect an input, and look, here's all the different inputs you could possibly have. Now, this is an introduction webinar. There are lots of other on-demand webinars. There's Jessica and I have one coming up in a couple of weeks too, on other projects if you're interested in learning more. But these are all different types of inputs that you can have. Ours is a temperature. You have to be real specific. We have one temperature sensor, so we're going to name it temperature 1. And then I also have to be very specific in saying, what do I want to connect it into or to? So I'm going to connect it to a port, and that port is going to be one of the either input, obviously 1, 2, or 3. And I'm just going to go connect it to N1. So I'm going to undergo menu. I'm going to hub because that's where everything is for the hub. And look, under A ports, there's all the ports. All right. So I'm just going to connect it to N1, and I'm going to get out of quotes. And then now I'm on the next line. So in basic, what you want the program to run needs to be within the quotes. And so that's some of the troubleshooting with students is the code language that the calculator understands needs to be in all caps as well as in quotes. And I like this. One of the newer updates, it's color coded too. So that's how you would set your program up for a basic, but either in 84 or in the Inspire. All right. Brad, you want to talk about Python, and then we'll go.
All right. Yeah. So
yeah.
Many of the commands are very similar. Like the fact that we do have to connect the hub, and we have to, get a temperature, set up into one of the ports, and also, we're gonna have to read it and we're gonna have to display it. So we're gonna talk Stacy through. She's gonna code this for us, right? And we're gonna see some of the similarities. And so we're gonna create this program on the CX2. So number 1, new. We don't need to save that. So we're going to go to Python. So A, and then a new program. All right. And we just could call this, I guess, Mood. All right. So now with Python, it's such a vast programming language that there's so many different commands, and that what we try to do here is we try to keep the files small. They don't always have all the commands available. So there are libraries of commands that you can call into the program that are the ones that you're going to use. It's not worthwhile to have every single command in a program if you're not going to call them. It helps with the efficiency and how quickly the program might run. All right, so, and this is all menu driven again. So if we press the menu key, we'll see a little bit of what's available. So now if we go, we're going to be primarily utilizing the hub. So we're going to go to number 8 with a TI hub. And then number 1 from TI hub import. So this will give us all the commands that the hub uses. All right, so that's a nice piece. So we want to use that. So number 1. All right. So now we need to we need to use that temperature sensor. All right. So if we go back to menu, again, it's in the hub. So we're going to go number 8. And a lot of times I have the students just take a look and say, hey, what are we using here? So we want to have an input piece here. So number 3 for add input device, and there's number 4 where it's temperature. Now what comes up here, you see we have to name this variable. All right, so for those familiar with Python, it's an object-oriented programming language. So what we're going to do here is we're just going to type in my temp. All right, and that's going to represent the temperature. And then as you see there, it's grayed out, but if we hit tab, the port. Now the nice thing about the Python is it automatically tells you what ports it's allowed to be in, right? So it doesn't even get, it's like, hey, you have to be in one of these 3. So we're going to choose in 1.
Which is always a problem for students. always they want to put it in N1, but then they program it out and vice versa. So I like this. This is good.
All right. So now one contrast to basic is if you're inside those quotes in basic and you hit return or enter, it will bounce it to the next line. In Python, you'll hit tab to get to the end of a line. Now you can hit return or enter. So one thing we want to introduce here, which is slightly different than the others programs, is TI has an RGB array of lights. So, you know, instead of that one little LED light, we wanted to light all 16 LEDs, make it really bold. So we can do that as well by doing menu and hub number 8. And then this one here is going to be an output device. And there it is, number 3, TI RGB array, right? Again, we have to have a variable here. So we might just call this ring because it's going to represent the mood ring. Right, and then there's nothing else there. So if we hit tab, and then we're going to be on the next line, I think, right?
Yep.
All right. So, all right. So one thing real quick, what we might want to do is we're going to set up a while loop. And in order to get out of this while loop, you have to press an escape button, all right, an escape key. And sometimes students might not know how to end this while loop, all right? So what we want to do is we want to display that text for the user to understand. So if we press menu, all right, and then we're going to go again to the hub, number 8. And then number 5, it says commands, what kind of commands we're going to use. And then we're just going to choose number 2 for text at. We can tell it where we want it to be on the screen. Oops. All right, so you just jumped to the while loop. All right.
I'm sorry.
No worries, no worries. We can put that back in there. All right. So in creating a while loop, so this get key, the exclamation point and equals is Python's way of writing does not equal. All right. So this is going to keep running until someone presses the escape key. All right. And that's very similar to the other 2 programs. Right. So now that we're in this while loop, all right, we have to get that temperature. So what we're going to do is we're going to go to menu. All right, and then the hub. All right, and then we got to go to where's the input, right? Yeah, so number 3. I believe this is it, right? And then temperature, I might have screwed this up. Go to 4. Oh, there it is. No, all right, so we just got to delete that. That's my fault. All right, so we're going to type in T equals. All right, so just do a space. 2 spaces, stays. There we go. Go T equals. All right, here it is. Now I got it. All right, so now we had to call the variable. The variable is my temp. So if we press the var key, which is right above the 9, there's our 2 variables. All right, so we press my temp. And now here's the key. If you press the decimal point, it'll tell you what that variable is capable of doing. So here it's going to measure. It's going to measure the temperature. So we're going to hit enter on that. And so now the temperature is going to be displayed as the variable T. All right. And so from there, we could put a display key to set this display line, which is in the code there, to show what the temperature is. All right. So we're going to put an if statement in here because we're running a little short on time. All right. So number 4, this is the only thing that's not going to be in the hub menu. It's going to go back into that control menu. So number 2 is control. And we're going to do just a plain old number 1 if. Right. And so here, our temperature, we want to tell it what to do. So if we could say T, and then we'll use the less than key if we hit control equals. And let's say it's less than maybe 22 degrees Celsius. So we're going to say less than, right, and 22. All right, so if we hit tab, we'll get to the outside of that colon. And then we're going to hit enter. So we want it to do something. All right, so here's the similarity to the other programs that are all written out. You can have it display a certain statement. And what we want to do is not only do we want to light up the RGB array, but we also want to put a statement in here. So here, Stacy just quickly shifted over to the program that we wrote. And so what happens here is on that line, just like we did before, Stacy, can you just go back to that other program real quick? Where we were just writing.
Yeah, we have about 6 minutes. So
okay, no problem. It'll be done in less than 6. All right. So here, just to show you, here you would put that the var, the variable, all right, which is our ring. and then we're going to press the decimal point. And it's going to tell you all the things that the array can do. So here, what we're going to do is we're going to go set all. It's going to light up every single one of the RGB array lights. And if we just put 255 for red, and then we could put 0 for green and 0 for blue, this would light the entire array up in red, right? So we just wanted to put that. That's how you can program this. And then you would keep repeating this step for different temperature ranges.
Absolutely, yeah. And so you're going to get this file as well. And so if you wanted to start with your students here, they have the temperatures and then what the array colors are, and then they could add the print statement of you are relaxed, you are calm, you are stressed. So I know y'all are dying to see it. So let me show you how this works. So I have both my 84 and my Inspire sitting right here. We're not going to have time for both. But so this is the temperature sensor that's plugged into an N1. And then the array gets plugged into the breadboard port, which I didn't really talk a whole lot. There's a whole project base that's just on the breadboard. And then here's the array. And so let me try to get my finger warm. When I run the program, it changes. I know it's hard to see the color change, but look how bright that is. Whereas typically it would be a little small, dim display just on the hub. And then, like Brad showed us, that there will be capabilities of changing the different number array ports or lights to be different colors if we wanted for different things. So that's the array. That's what the hub looks like set up. I always have my document camera up. I show my students what's happening, and then I share it with them, and then they're able to build on the programs as well. So if you want to do this, right, this is you're like, hey, I'm hooked. I want to try some of this with my students either this year. TI has an entire website called STEM Projects. The STEM team's email is at the bottom. When I tell you they answer their emails quickly, it's not like it's somebody in an office somewhere and you never hear from them. They are very user-friendly. They were classroom teachers, most of them like us, that will answer your emails. These are the STEM projects that we were talking about that Brad and I start, and then all of the documents that are there definitely makes it so that you can download everything. So here's the mood ring. Like I said, it's in Python, CE, and the CX. Pet car alarm, my students did that project as well. This was the smart irrigation I was talking about. The music is how we did our jukebox. Here's the array Brad's talking about. This is a sensor link. It uses the veneer sensors. One of my favorites is this heart one where we actually show using LEDs to actually show a beating heart, and we shock it and we make it come back out of ventricular fibrillation. Also cool. So that's kind of where you can find those. And then if you want Brad and I's contact information, there it is again. I know that was a lot in an hour. And Mike, I know we really ran short on time, but thank you guys so much.
Thank you very much.
No problem. Thanks so much, Stacy and Brad. We're going to start wrapping things up tonight. First of all, to receive a certificate of attendance, please go ahead and click the link in the chat window. Also listed is a link for the documents, and like Stacy and Brad mentioned tonight, there's a lot of documents. So be ready and be excited. There's a lot in there. If you're not able to access these links for any reason tonight, just hang tight. You'll automatically get that follow-up email that Stacy had talked about earlier, where there'll be links to the recording so you can watch this at your own pace, links to the documents, and links to the certificate as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Other than reaching out to the STEM team, if you have any just general knowledge questions for TI, please give us a call at 1-800-TI-CARES, or give us send us an email at ti-cares@ti.com. So again, huge thanks to Brad and Stacy for everything you really took the time to put together and share tonight. I had no idea there were so many uses of coding and STEM projects in the classroom. Thanks so much.
Thanks for having us.
Thank you.
And thanks so much to everyone who joined us tonight. We hope to see you back online next week. Have a great night.